Today, I'm going to teach you advanced breadth first search. Previously, we did breadth first search with a tree. Today, let's do it with graph. As we discussed, a tree is a part of a graph. Compared to tree, graph can have cycle and can be disconnected. Here is a graph. Graph is a set of vertices and edges. We can represent the vertices like this array. How can we represent edges? For the node 1, node 2 and node 3 are connected to it. We can represent each edge like this. There are all 2 edges for node 2. Finally, here are the all edges. Sometimes, people call it adjacent list, but it's not important. Now let's start BFS for the graph. Compared to previous code, there is no left and right child. Therefore, use for loop instead. First breadth. Print 1. Now iterate over adjacent nodes. Put 2 onto the next queue. Put 3 onto the next queue. Both for loops are ended. Copy the next queue to queue. Clear next queue. We can improve the code like this. Now next breadth. Print 2. Put 1 onto the next queue. Put 4. Now focus on the node 3. Put the adjacent node 1 to next queue. Put 4. Second breadth is the end. Third breadth. Print 1, but take a look at this. 1 is printed again. Moreover, we put 2 and 3 onto next queue again. For this reason, there will be infinite loop. Cycle. How can we prevent it? Use a new data structure, visited. Let's add these 3 lines of code, and do it again. 1 is not in the visited, so put it into visited. Print 1. Same as before. Put the adjacent nodes onto next queue. Now second breadth. Cause 2 is not in visited, put it into it. Print 2. Save adjacent nodes. Mark 3 as visited. Print 3. Save adjacent nodes. Now third breadth. Cause 1 is in the visited. It will not touch the following lines. What about 4? It's not marked to visited. Therefore mark it as visited. Print 4. Put adjacent nodes. Same thing. Skip it. Skip it. Queue is updated, but 2 is in visited. Skip it. Same for 3, skip it. For loop is ended and update queue with the next queue. Queue is empty, let's call it an end. As you can see the output, we all iterate node and print them. We solve the cycle issue with a new data structure. What about the second difference? Sometimes, you should care about this separate graph. Here is a solution. Please take a look at it by yourself. Finally, what is the time complexity? Graph is a set of vertices and edges. Cause we iterate all vertices and edges, time complexity is this. Thanks you for watching this video.